Hi again. Welcome back to At Home Math. Tonight's lesson is 10.7 on page 540 in your book. It's on similar figures. Similar is indicated by this little squirrely sign, tilde, there in purple. Similar figures are shapes that are the same, figures that are the same shape, but not necessarily the same size. They can be the same size, but then they're also congruent. All right, so here's an example. This is a reproduction of what's in your book on page 540, but I did add some nice colors, so that should be good. All right, so I have this triangle and this triangle, SRT and ZXY, that are similar. And so in a similar triangle, the sides that match are called corresponding sides, and the angles that match are called corresponding angles. And what I mean by match is not necessarily that they're the same color, that's just to help you pick those out, but that they're in the same position in the figure, okay? So in this example, the line SR and ZX are corresponding. ST and ZY are corresponding, and the green ones, RT and XY, are corresponding. Likewise, the angles. Angle S and angle Z are corresponding, angle R and angle X are corresponding, and angle T and angle Y are corresponding. So an important fact about similar figures is that if two figures are similar, their corresponding sides are proportional and their corresponding angles are congruent or equal. What do I mean by this? Corresponding sides are proportional. I mean that the ratio of a pair of matching sides to another pair of matching sides is equal. So in our previous example, SR was matched with YX. That ratio would be equal to the matching pair of ST and YZ, and also RT and XZ. Okay? Very important fact, which you will remember, right? So if you look at example 1 on page 541, I can use the fact that corresponding sides are proportional in order to determine whether two figures are similar. So in this example, I want to know which trapezoid is similar to trapezoid DEFG. That's this one, DEFG, and it has side EF is equal to 4 and GF is equal to 12. And my options are A, B, and C here. This trapezoid, PQSR, WXYZ, JKLM. The corresponding side to EF in this one is QS, and to GF is RS. So what I do is I set up those proportions and I see if they're equal. So EF to QS is 4 to 6, which simplifies to 2 over 3. GF to RS is 12 to 14, which simplifies to 6 over 7. Those two aren't equal, so that these two are not similar. Those two trapezoids are not similar. So try the next one, WXYZ. Again, this is corresponding to this. So I have EF to XY is 4 to 3. And GF to ZY is 12 to 9, which simplifies to 4 over 3. These are the same. So these two are similar trapezoids. And just for completion's sake, if I do the same thing with JKLM, EF to KL is 4/5, and GF to ML is 12/10 or 6/5, and so those two ratios aren't equal either. So this is our winner, WXYZ. So here's your first problem for this lesson, 10.7. It's which triangle is similar to triangle DEF. Here's DEF, DEF. This side measures 6, this side measures 15. Here are your options, triangle XYZ, triangle ABC, and triangle RST. If you can't read these numbers, I'll read them for you. It's 8 and 20, 4 and 12, and 3 and 6. That's your mission. Let's look at the answer then. Check your work. If you said angle ABC is similar to, or triangle ABC is similar to triangle DEF, you were right. Let's look at the ratios. DF and XY are corresponding, and that ratio is 3/4. FE and YZ are corresponding, and that ratio is 15 to 20 or 3/4. Whoops. Sorry about that. This is your winner. I hope you guys weren't crying because you thought you got it wrong. Sorry about that. Okay, but let's just go through the rest of these for the sake of completion. DF again corresponds to AC. That's 6/4 or 3/2. FE corresponds to CB. That's 15/12 or 5/4. Those are not equal, so these two triangles are not similar. And the last one, DF, corresponds to RT. So that's for good thing you're here to check me. 6/3 or 2. And FE to TS is 15/6, which simplifies to 5/2. And again, these are not equal. So these are the equal ratios. These two are the similar triangles. If I know two figures are similar, I can find missing side measures. So example 2 on page 542. Find the side measures of similar triangles. I have two similar triangles here, RST and XYZ. And I have a missing measure. I don't know XY. So there are a number of proportions that I can set up here, but so just choose one. In this case, we can set up the corresponding ratio of corresponding sides RT to XZ and RS to XY. I know this relationship, so RT to XZ is equal to RS to XY. I know that's true because they're similar. Okay. I know RT's length at 6. I know XZ's length, it's 18. I know RS's length, but I don't know this one. So I set it up as a proportion. I know in a proportion the cross products are equal. So 6 times n is equal to 18 times 4. 18 times 4 is 72. So now I have 6n is equal to 72. I divide both sides by 6, and I get n is equal to 12. Okay, this is problem number 2 for the homework folder tomorrow. If triangle ABC is similar to triangle EFD, find the length of AC. So I'm missing this length. I'm just going to tell you to be careful. Remember the definition of corresponding sides is sides that occupy the same position in the figure. And I draw your attention to the right angle. All right, good luck. Okay, in this situation, this triangle is sort of flipped over and upside down. So the corresponding sides here are AB corresponds to EF because it's in the same relative position to the right angle. And AC corresponds to ED. So I can set up this ratio. Again, I could have set up different ratios. I could have set up a ratio that included these two measures. But AB to EF is equal to AC to AC over ED. AB is 28, EF is 4, I don't know AC, and ED is 3. Again, I take the cross products. 3 times 28 is 4 times n. It's equal to 4 times n. 3 times 28 is 84. So I divide both sides by 4 to isolate n, and I get the length of AC is 21. All right, that's it for tonight. Have a good night. We'll work on these again tomorrow, and take care.